Hello student, in this video I will be discussing what is polarity of bonds. So you see that H2 molecule is there, O2 molecule is there, N2 molecule is there, Cl2 is there, F2 is there, Br2 is there. They are non-polar molecules. Why they are non-polar molecules? Because the electron is symmetrical around the nucleus, between the two nucleus. So there is no electron, like if you see HH atom, electronegativity is 2.1. So if you consider HH atom, electronegativity is 2.1, 2.1. So there is no difference between the electronegativity. So it is regarded as non-polar covalent molecule, and their dipole moment is 0. Their dipole moment is 0. So dipole moment is the product of charge into bond length. Dipole moment is the product of charge into bond length. So if dipole moment is 0, the molecule is said to be non-polar, and if it is non-zero, then the dipole moment is said to be non-zero, then it is polar covalent compound. It is polar. So HF you see. So in case of HF, if you see HF, then there is a electronegativity difference between fluorine. Fluorine has 4 electronegativity. Hydrogen has 2.1. Hydrogen has 2.1. So there is a electronegativity difference between these two. So it is a polar molecule. So HF is a polar molecule. So it has a dipole moment which is not equal to 0. Which is not equal to 0. Now let's see what is dipole moment. So dipole moment is the product of charge into bond length. It is a vector quantity, meaning that we have to find out dipole moment on the basis of vector addition, and its unit of dipole moment is dvi. The unit of dipole moment is dvi, and 1 dvi is equal to 3.33 into 10 to the power 30 coulomb meter. Coulomb is the SI unit of charge and meter is the SI unit of length. So if dipole moment comes out to be 0, then the molecule is non-polar, and if it is not equal to 0, then it is polar. Now let's see few molecules which seems like they are polar but they are actually not. CH4, BF3, CCl4, BH2, BF2. So let's see BF3. So if you see the BF3 structure, so the dipole of this will be cancelled by this, resultant of this. So it has polar bond, but overall the dipole moment is 0, suggesting that BF3 is non-polar despite having polar bond. Due to symmetrical arrangement, CH4, CCl4 and BH2, BF2 all are non-polar. So every case the dipole moment is 0, so they are regarded as non-polar molecule. The carbon-hydrogen bond is practically taken as non-polar. So CCl4, all the dipole will cancel each other. Similarly in case of BH2, BF2, so these are all non-polar molecule. Keep this in mind, student. This is very, very important. Now, in case of HF, HCl, HBr, HI, water, hydrogen sulfide, these are all polar molecules. So their dipole moment is not equal to 0. Like in case of water, the dipole moment is 1.85 dvi. So water has a very high dipole moment. It is regarded as a polar molecule and it is a very good polar solvent. So water is very, very important. If you see the molecule carbon dioxide, so it has 2 double bond with oxygen. Carbon has 2 double bond with oxygen. So double bond with oxygen, double. So individual dipole will cut because oxygen is more electronegative than carbon. So this dipole will go this direction. The direction of the dipole is from positive to negative with the line cut near positive. So these two individual dipole will cancel and it becomes, despite having polar bond, carbon dioxide is a non-polar molecule. It is a non-polar molecule. Now let's discuss the dipole moment of ammonia. So the dipole moment of ammonia is more than dipole moment of NF3, because here in all the direction of all the dipole, individual dipole is in one direction, but that is not the case in case of, because fluorine is more electronegative than nitrogen, nitrogen is more electronegative than hydrogen. The electronegativity of fluorine is 4, the electronegativity of nitrogen is almost 3, and the electronegativity of hydrogen is 2.1. So if you see their individual dipole, you will see that in NH3 all the dipoles are arranged in one direction, but it is not the case in case of NF3. Therefore, NH3 has more dipole moment than NF3. This was asked in IIT student. If you see the direction of dipole in case of ammonia, this is this direction because nitrogen is more electron. This is this direction. This is this direction. Here is the nucleus and this is the lone pair. So this is also. So all the dipoles are in one direction. So the dipole moment is high. So which is 1.47 dy. If you see NF3, the dipoles are in this direction because fluorine is more electronegative. And this dipole is in this direction. So overall the dipole direction is this, and some of it is cancelled by this. So therefore the dipole moment decreases and it is 0.23 dy. So the dipole moment of NF3 is less than dipole moment for NH3. So NF3 has lesser dipole moment than NH3. So this was asked in IIT student. Keep this in mind. Thanks for watching this video. Do like and subscribe my channel.